collaborative robots. When I asked to deliver a lecture, I thought it's about the audience will be from the computer science because the title of this event was artificial intelligence. So I prepare very basic stuff related to the robotics and the the collaborative robots. So anyway, I hope to provide a very fun and some interesting stuff for you, and I hope to somehow inspire you and try to provide visions for the next future robotics in my lecture. So I don't want to bore you, but I'm trying to be funny and fun. Okay. So first, I briefly introduce some of my research in my lab. The main research goal in my lab is to design and control a robot with advanced manipulation and mobility. So in my lab, we design some soft robotics, the soft robot and some bio-inspired robots. And we also design hybrid mobile, which can provide advanced mobility on several different terrains, including rugged terrain. So in this slide, you can saw some of these robots. So this is a soft glove system of can be used for the rehabilitation. And this is a robotic hand actuated by a soft actuator. And in our lab, we typically use shape memory alloy material in order to actuate robotic systems. So to actuate the SMA, we usually use electric energy. So in this case, we use IR camera to capture the change of the temperature on the SMA wire or SMA material. And we also designed several different hybrid mobile robots. And I also use collaborative robot to do some small projects or to help students to understand the basics of the robotics. So I would like to talk about some fundamental stuff regarding the robotics and collaborative robots. Then I will maybe briefly, uh, discuss about the recent trend in technology and the some industry or markets. Then finally, I would like to discuss about the future research opportunities and comparing the traditional approaches in the robotics research. First, I would like to show a couple case studies which is using the robots in some industries. Uh, First, I don't see the video is playing, but can you see the video clips? I don't see.
No, Professor, the video is not visible.
Okay. This is not working, maybe. Okay. Let me try to okay.
Yes, now working.
Now it is
Okay.
visible.
Okay. So some company in USA claims that Yeah, some company in USA mentioned they can boost production 200% and 600% on the uh, machine tending. So okay.
Professor, I think can you increase the volume of this video? I think people,
Are you saying the volume is small?
yeah, people are asking the volume of that video.
Okay, okay. Let's see.
Yeah, if possible.
Let me try. Uh, is it better?
Okay, continue, Professor. I think it is not audible. Please continue. No issue.
Okay. Anyway, the thing is that the company uh mentioned that they have some difficulties in hiring peoples there, and you know, so they somehow want to apply the robots in their company. So dramatically increase the predictability by using the collaborative robots in their workplace. And the other case is Japan. So anyway, in Japan, this company also save monies by applying collaborative robot in their workplace. In everywhere, there are labor problems. We want to hire peoples, but we cannot because there are not many skilled labor forces. So this is one of the big issue in everywhere, I think. So that's why people want to use robots in the workplace. Okay. So, we can think about why we want to use robots in industry or in our daily life. So it is very clear and very common of using the robots. So one of the big issue, I mean, but one of the big benefit is automation. And by achieving automation, we can improve accuracy and the precision. Uh, we can also obtain, I mean, we can get the better efficiency and better decision making, and we can increase the productivity, and we can also create a new service or better service. So ultimately, we can save monies by using robots and, and AI. So ultimately, the our goal is to improve our life, quality of life. That's our ultimate goal when we try to use robots. So by using the robots, our life should be safer and we are more satisfactory. The one of the leaders in the collaborative robot industry is Universal Robots, and they performed some survey in 2024, and they ask, are they using some new technologies? And one of the top technology used in the industry is AI and machine learning, and the other one is digitization and robotic automation. So those are very some popular technology these days. And they ask why they want to use this new technology. So as we can easily understand, they want to improve the productivity and quality and accuracy. And they also want to save monies. So when we try to use new technology, there are some hurdles or some obstacles. There are some, one of the big hurdle is, usually, I mean, the new technology should be easy to use. You know, it should be very easy to use for everybody. Otherwise, new technology cannot be applied. And it can also provide some good quality of the outputs. So those are one of the important things when we try to use new technology and when we try to adapt new technology. And in the future, these they ask which of these technologies would be considered in the near future. So one of the top is AI and robotic automation. So people want to use new technologies in their industry to improve productivity and the quality of the outputs. It is clear. Then I would like to talk a little bit about the definition of the robots, and I would like to ask what is a robot. So some people think somewhat differently about the robots. When I talk to somebody who is from the technology or who is not familiar with robotics, they think humanoid robot is the only robot they believe. So when I talk a person, they think uh, robot is the yeah, robot should be like a human being, and it should be very efficient and precise and very smart, they think. However, robot is a little yeah, different technically. First, I searched robots in Google News, and you know there are some interesting articles. China to host world's first human robot marathon, and I can read the tiny insect-like robots and some humanoid robots. So I also searched collaborative robots in Google News, and I see a bunch of the collaborative robot here. So I also searched some robots in Google, and this is typical robot images found in the Google search engine. So they are almost humanoid robot. A robot can be classified as industrial robot and the service robot by considering applications, as you may know. So I also searched the industrial robots, and those are some typical images found in Google's. And typically in industry, they use manipulator robot to handle objects or carry some objects and pick and place, and welding and painting and uh, other heavy loading jobs. So these robots are composed of the links and joints and some end effectors for very different jobs. This is very typical industrial robot. These robots are operated without human because uh, it is very dangerous working with this industrial robot because they're very fast and heavy. So those typical industrial robots are operated without human. And these are service robots, which is not used for manufacturing. They provide some service for human or and maybe animals or other robots. They're providing service. So in this search, most of the service robot looks like humanoid or similar to the human kind of. And I also found several images regarding collaborative robots. So in this search, most of the robots are manipulated robot. However, these robots are quite different from the industrial robot because these collaborative robots are smaller and a little safer because they have some sensors to detect collision. So it can be somehow safely used uh, and can walk with human beings. And they're a little bit slower. So, you know, they can be used to walk with human beings in a some space. And they can perform more complicated walks, and they can assist human beings. So today I would like to a little bit about the focus on the collaborative robots rather than the industrial robots. Okay. So first, when you say a robot, it is generally a intelligent robot. So robot is basically a machine. However, it can provide some capability to understand environment and make some decision and take action and interface with world, including other robots, humans, and surroundings. So these are typical images of robot, I guess. However, you know, with the significant advancement in the AR, artificial intelligence technology, we we see some new paradigms in robotics. So one of the new paradigm is physical embodiment, which allow robots or AI to perceive and interact with physical world somewhat intelligently, similar to a human being. And second paradigm is a general purpose robot, which means it can behave like a human. I mean, it can perform variety of tasks like a human being. This I mean, the typical robot can specified for very special task. However, these general purpose robots can perform many different tasks like a human being. So it's like maybe a humanoid robot. So it can drive, it can do housekeeping, it can cook, or it can work in factory instead of a human being. So physical embodiment and general purpose robots, general robotics are new paradigm for robotics. This is brief history of AI, and there are many big events. So Turing test in 1950 and backpropagation in 1986 and CNN 1998. Recently, GPT, I mean the Transformer in 2017 and GPT and ChatGPT in 2022. So with uh, dramatic advancement in the AI technology, uh, we also see very impressive advancement in robotics. This slide show a brief history of industrial robots. So initially, the robot was introduced to handle very dangerous tasks in nuclear reactors. Then the robot uh, has been applied to the automobile industries. In 1960s, GM uses Unimade in their factory. And in 1980s, uh, the programmable robot has been used to perform precise tasks. And in 2000s, uh, collaborative robot was introduced. Collaborative robot is uh, is designed to work with human beings. So it is more safer, as I mentioned, and more user friendly. So we can control robots more easily. And in 2010s, AI has been applied in robotics research, and we can observe significant improvement or enhancement in robotics research. So, oh, yeah, one of the questions I asked before is what is a robot? According to the old definition in 1980, the robot is a programmable, multifunctional manipulator. So it can be programmed to perform variety of tasks. So basically, the robot was a manipulated robot, which can be used in industry or factories. For example, automobile industry use a lot of robots for weldings and assembling. So robot was basically robot arm, which can handle objects or some products and some materials. However, this is very limited definition regarding the robots. These days, the range of the robot is quite broader. So sometimes we call the general electronics as a robot. Sometimes, microwave can be considered as a robot, maybe. I will skip some video clips. Then, these days we robot include many different types of systems. So it could be mobile platform, it can be autonomy machine or man-machine interaction in tele, robotic, and virtual reality systems. So robot can be a mechanical or virtual intelligent that can perform some tasks. However, usually when we mention a robot is electromechanical machine, so it has some physical body. The robot can be operated uh, by remotely or semi-autonomously or fully autonomously. Or as the robot is combined with AI, we sometimes call robot as a physically embodied AI. You know, since the robot is combined with some physical body and AI, the robotics the robotics deal with uh, many different disciplines. So, in robotics, we deal with the design, construction, operation, and use of robots, as well as computer systems, controls, and programming, and sensing, and so forth. So, robotics is interdisciplinary branch of engineering and science. So, one of the three majors involved in the robotics are mechanical engineering, computer science, and electrical engineering. Then I would like to briefly talk about the elements of the robots. So, in physical robots, what is the component of the robots? So we can divide component robot into five elements. So first, robot should have mechanical structure, the body. So it has some bodies and mechanical parts. And in order to move the robots, we need the actuator. So traditionally, we use actuators such as motors, these motors, electro, electrical motors, and hydraulic and pneumatic actuators are also popularly used. However, these days, in robotics research, we want to make a more flexible and more soft and bio-inspired robots. So in order to provide new types of actuation, uh, we need a more soft, compliant, more novel actuators. So there are many ongoing researches in smart actuators, including the muscle wire or shape memory alloy or piezo electroactive polymers. So those are very interesting research areas. And then we also need the sensors for perceptions. So in order to understand the environment of the robot, robot have to use sensors like a human. We have, eyes and visual sensors and the audio sensors and tactile sensors. So robot can use some cameras and microphones and other sensors, pressure sensors and the force and torque sensors to yeah, understand environment. And in order to make some decision and understand the environment and make a decision and actuate the generate some command for the actuators. Robot also need the controller. In controller, we can think about the hardware control board and some control laws. And we also need power source in actuate the robots. So, you know, the battery pack could be applied to actuate the robots. Those are five elements are key elements in a robot system. So in a in a typical industrial robot or manipulator robot, robot has the bodies. So as you can see, this is a body, and there are some camera systems, which is a sensor, and there are also force sensors. There are force sensors, and okay, my my daughter is
Yeah.
attending me. Okay. Anyway, sorry about that. So anyway, so you know, there are controllers, and this is teacher pendant, which is also a controller, and PC can be a controller. So and there are power source from the DC or batteries. So this is basic yeah, element for the robot. We can classify the robots in many ways by considering application. Robot can be divided into industrial robots and service robot. Service robot can be divided into two categories, which is professional service robot and personal or domestic service robot. So this is very typical classification of the robot. There are many kinds of applications actually. So industry and defense and security and medical transportation and consumer or personal or entertainment, education, and so on. And we can also classify robots by considering the design and the mechanism and the shapes and the size and the materials and the control method and the operation of the robots. There are many yeah categories. So we can consider mobility. So there are mobile robot and fixed robots. In mobile robots, in a mobile robot, we can use wheels and legs and many of the yeah mechanism to provide mobility for robots. Some regular robot, wheeled, tracked, and hybrid robots are available. And for typical industrial robot, we can say Cartesian articulated or dealt or parallel robots. And more recently, people are interested in bio-inspired robots, which include humanoid or biomimic or insect-like or animal robots. And typical robots are rigid or hard robots, but recently, particularly in the bio-inspired robotics, soft robot is one of the interesting topics. So we want robot to be more natural and somehow more compliant and flexible. So we see a lot of soft robotics these days. And according to the size of robot, we can classify robots micro, nano, or gigantic or miniature robots. So robot can be also classified considering the locations where they are used. So ground or aerial or underwater or on the surface of the water maybe. Or by control method, we can say teleoperated robot or autonomous robots. So when a robot, when a single robot is used, we can say single robot and multiple robot may be used, or it can be behavior like some insect in a swarm. So we can say swarm robots. So there are many interesting classification by considering many aspect of robots. Okay. So, since the title of my talk is, I would like to talk a little bit about collaborative robots. So, as I mentioned, collaborative robot may be called as cobot in short, cobot. So, when we think about the collaborative robot, it is basically the manipulate a robot, but it's more safe and more smaller and lower payload and slower and easy to use compared to the industrial robot. Typical industrial robots are larger and heavier and faster and somewhat dangerous. The collaborative robots are more popular in these days. However, collaborative robots sometimes applied for some service robots. So yeah, typically the collaborative robot may be considered as an industrial robot, but It may be also considered as a kind of the service robot sometimes, combining by the some mobile robots. So, you know, in many applications, actually, by combining the collaborate robot with the mobile robot, uh, you know, collaborative becomes somehow mobile, and we call it a manu mobile manipulator. Mobile manipulator becomes more popular, and it can be applied in many applications, maybe in the small factories or in the some agricultural applications, or it may be applied for many gardenings or cookings maybe. So somehow it's in the middle of the yeah, collaborative robot is in the kind of in the middle of the industrial robot and the service robot. So this slide showed the simple demonstration of the collaborative robot in my lab. We have a multiple UR robot, universal robots, and I use this robot for my lecture, robotics lectures, and the laboratory lectures. And this robot can be controlled by using several methods. One of the easy 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 way is to using the teach pendant. This is a teach pendant provided by the manufacturer. This is a uh, kind of controller, so you can control these robots, and you can do a program. So in this screen, you can see the workspace or some space. The program you can put your programs in these columns by dragging command or adding the command. So this big button is emergency stop, just in case you may push, but it should be usually safer. And the other way to control the robot is using the PC, and you can program using you can use many different languages, computer program languages such as Python and uh, C plus maybe, and the MATLAB and many other tools or programming languages to operate these robots. Uh, I will show some clips. This clip has been used in my lectures. So we generated some code for the robot by using Python, and we control the robots using Python command. We can yeah, operate the robots, and this might be a little somehow difficult for the general users, but we can use a Python code, and we can also use ROS, uh, robot operating systems as well. But one of the easiest one is using the teach pendant and using the built-in command, which is generated by, which is provided by the manufacturer. That's one of the easiest one, I guess. Okay, then I would like to talk a little bit about the uh, technology and the market trend in robotics and collaborative robots. Okay, you know, the world is changing rapidly. So the first thing is, you know, there are huge technological advancement in AI and robotics. So, you know, the ChatGPT and the other GPTs. So they are trying to be a somewhat uh, new. I mean, they provide a very a variety of services. These GPTs. So recently uh, these Chat GPTs are used to control the robots, which is very interesting. And the other trend is economy becomes digitized. So, after the COVID, many things are digitized. We want to use many new technologies and many services are provided online. And the other change is uh, demographics. You know, population is decreasing continuously. Uh, so that's a big problems in South Korea as well as other advanced countries. So people are getting older. So it is very difficult to find someone who can work. That's yeah, one of the big issue in some countries like South Korea and Japan. And we have very rapid decrease in uh, birth birth. So that's one of the yeah big issue in uh, recent years. And we also really care about the sustainability and the environmental issues. And there are also big changes in global market. We observe many big issues in global markets, reshoring or nearshoring, and trade tension between especially the China and the USA. That's a big issue, and it increased the unpredictability in the market. And we also observed many supply chain vulnerabilities these days. So those are mega trend in technology and our environment and the global market. So first, I would like to talk about the technology trend. So in this slide, you can see the top five global robotics trend in 2024. This information was generated by the International Federation of Robotics, IFR. So one of the first yeah issue or topic is AI and machine learning. That's the one of the hottest topic in the world, I think. And second one is collaborative robots. And third one is mobile manipulator, which is combining collaborative robot with mobile robot. So, collaborative robot becomes the mobile, And fourth one is digital twin, and fifth one is humanoid robot. So second and third are associated with collaborative robots, and these robots also converged with AI as well. And I will show short video clips from the CS Consumer Electronics Show 2025, hosted, held in Las Vegas a couple weeks ago. In in this CS 2025, some of the main keyword was artificial intelligence and robotics and mobility and sustainability. So, you know, there were many uh, the products which is using the AI. So AI agent was available in many services, and AI is combined with robotics. And also the AI is applied to the self-driving car. So these AI and robotics are one of the popular technological trends these days. And the NVIDIA CEO Jason Huang mentioned that AI revolution is on the verge of delivering breakthrough in robotics. And he said Chat GPT moment for general robotics is just around the corner. So he mentioned that there are new paradigm for the robotics. So as I mentioned earlier, embodiment of the AI and the general purpose robots. Those two are the future robotics, future robotics. So he mentioned many interesting stuff during the CES 2025 conference. He mentioned that the future will be physical AI, and the robotics will be important application. And he mentioned that he briefly showed the history of the AI. So from the perception AI, generative AI, and nowadays the AI agent is available. And the next AI is physical AI, which means self-driving cars and general robotics. So AI can be somehow realized in real world. And up until now, the AI exists online or virtual world. However, in the future, AI can interact physically with the human being and robot and other systems or environment, literally. So that'll be a physical AI. That'll be a future of the AI and we'll see interesting AIs soon, I guess. So I will show short video clips. Okay, Jason Wang mentioned that the robotic air is just around, and uh the general purpose robot and the physical AI is the future. However, the one of the difficulty is training the robots are really difficult. There are some challenges and some issues uh, with robotics. So NVIDIA tried to provide some platform for training robots by using foundation models. So, one of the future research topic for the robotics is the uh, foundation model. I mean, the robotic robot foundation model, I guess. One of the good thing about the AI is, we don't need programming. I mean, specific programming. Uh, Hard coding is not required by using AI. That's one of the really cool things. Previously, in order to operate a robot or make things work, we have to uh, do hand coding, and we have to put all the instructions specifically, which is not realistic in very complicated task. Particularly if we want to control robot in a high level of degrees, it is almost impossible to control robots by using traditional rule-based or traditional hand coding. However, with the recent develop, I mean, with the recent advancement in machine learning or neural networks, we can ask, I mean, that we can teach the robots to do some very complicated task. So that's very cool and very interesting. So that's cool. But however, the issue is how we can train the robot. That's one of the big challenges. So, the recently people think somehow we want to use multimodal data such as our voice or command voice command, and some text and video clips to train the robots. Like you can we can literally command by using our voice to control the robots by using generative AI. So we may not use directly program to make the robot to work for us. So that sounds really interesting. However, it is not easy one as you may understand. So NVIDIA and other researchers try to provide foundation model which can be used to train robots or self-driving cars. So idea is that we collect some inputs from the many different types of sensors, and it can be image or it can be video clips, it can be some text, it can be some sensor information from the IMU or accelerometer IMU or LiDAR or whatever. Then all those multimodal data can be input to the foundation model. It can be a world foundation model or robot foundation model. Then it can generate some some specific actions for robot. So this foundation model can understand the physics of or dynamics of the world or environment, and they can perceive and they can plan task or plan actions or they can do some low-level control, and they generate some specific actions or some high-level actions or low-level actions. Then uh, it can be fed back. I mean, it can be used in robot directly. That's the one of the interesting the research topic recently. So this shows the foundation model for general robotics. So by using these schemes, if we build, I mean, if we can build a foundation model for a robot, we can control. I mean, we can control every robot using this AI or these models. So we can use all kind of datas, and robot understand the environment, and it perceive, it understand the command or task itself. Then it generate the command for robots. So we can train the robots virtually using this model without physical robot, maybe. As you may understand, the training robot is very risky and expensive and very dangerous. And also, it is very difficult to collect data. You know, Up until now, the robot is designed for a specific task that's very typical. So, every data from the robot is very typical for very specific task and robot platforms. So it's not. I mean, the single data cannot be applied to another robot. So that's one of the issues in the data. So data is not available. I mean, rare. The data are rare. So if we can build foundation models, we can overcome those big challenges in training robots. So by using these foundation models, uh, we can train robots virtually, and physically we can train as well. Then we can save a lot of times and the cost. So I believe this approach, foundation model and general robotics, are the future robotics, and we can see a lot of research opportunities uh, in foundation models and general robotics. However, we need the more research because this technology is not yeah completed yet. We have to spend much effort to improve these ideas and somehow realize this uh, uh, the models. And this slide shows some examples how these foundation models are used and or what kind of model can be applied. And as I mentioned earlier, there are still a lot of issues and challenges in application of the AI in robotics. As I mentioned, data is scarce. You know, data we collected from the robot may not be applicable to other robots, and collecting data is uh, not easy. Is and the as I mentioned, the generalization of the data is not easy. One single data, I mean the one model may not be applied to other robots, and single data may not apply to the other systems, maybe. So generalization uh, data is not somehow in some cases data is not available. So we also have to consider uncertainty and the safety in robots. And also the task also, we for the general purpose robot, robot should perform variety of tasks. However, it is not easy one. How to somehow uh, plan how to plan the task and generate the command right for the um, general purpose robot are very challenging, I think. I I searched some the research papers and I collected. I mean, I tried to analyze the number of the papers regarding the AI and robotics. So I analyze these data. So I analyzed the number of the papers by year, and as you may see, the as the AI, I mean the advancement in the AI technology, the papers significant. I mean this the paper a number of the paper significantly increased after maybe around 2016. The paper has been paper last year it reached almost 10K, and I also analyzed the number of the papers by countries, and as you may see, the China and United States are dominant. They are actually dominating the research in AI and robotics. And India is third place. However, the uh, China and the United States are really dominating this research. They are leading this research, and South Korea is over here. And the discipline of this research are mainly engineering and computer science. I also analyzed the number of the papers in the embodiment of robotics. And this is a little bit new research. So you can see a small number of the papers here. So this is new, maybe new and somehow young research topic, embodiment. And this area, the United States are leading this embodiment research. I also searched the some papers regarding the foundation models in robotics, and number of papers are smaller. Number of papers. So there are some big opportunities in foundation models, I think. So leading countries in the foundation model is again the China and the United States. So those are foundation models and the embodiment of AI in robotics are pretty much young, and we can see a lot of opportunities in those two research areas, I think. I also uh, briefly mentioned the market trends in robotics. Hopefully, I want to be short. So, recently, more than 4 million industrial robots are operating around the world. 4 million industrial robots. That's quite large, I think. Annual installation of industrial robot exceed 500,000 units these days. And the major industry which is using robots are automatic, auto, automotive and electronics. So those are the two main application of the industrial robots. And industrial robots are used to handle and weld, assemble mainly. As you may see, the Asian countries use a lot of robots, almost four 400,000 400,000 units are used in I mean they installed in Asian country annually. However, Europe and the American, the number of the installation robot are a little smaller. So Asia is the biggest market, I think. Yeah, one of the very interesting fact in robot installation, China is really dominant. So they take they install almost 50% of the robots in the world. So they're really amazing. And Japan and United States and the South Korea comes next. But you know anyway, these top five countries take almost 80 of installation in the world. They are dominating actually. China is actually one of the biggest country, and India is right here. So in India, uh, what annual installation is about the 8.5 percent. Nine, the number of the installation is 8,000, 8,000, I guess. Okay, so number of the robots in China is really huge, huge. So major application is automotive and electronics as well. And one of the interesting thing is that Chinese companies are very competitive. They have a strong they are very they making a lot of robots and they taking a lot of shares in the market. So Chinese robots are really yeah, interesting and amazing recently. And I will go faster. This is data from the Korea, and annually we install 30,000 units annually. And again, the major application is automotive and electronics. This is expectation of installation in future. However, there aren't significant increase, but it'll keep going, and the number of the installation will go on. Okay. One of the interesting things that robot density in manufacturing industry. So the world average of robot installation per 10,000 employees is 160. 160. That's the average number of installation for 10,000 employees. However, in South Korea, its installation density is really higher. So we have high density of robots in the world. And next one is Singapore, China, Germany, and so on. I don't see the India here, but I think the number of the installation in India is also increased significantly compared to past years, I think. And this slide shows number of manufacturers by applications. And you can see the transportation and logistics are one of the major applications. And next one is a professional cleaning. Okay. And this slide shows some of the yeah, interesting things as well, I guess. So it showed the global startup heat map in robotics. So you can see the big dots in United States here in California, maybe, and some UK and France and uh, I'm not sure about this country, maybe Holland, maybe, or Netherlands. And we can see the big dots in India and China, Japan, and smaller one in South Korea. So I guess India has good potential in robotics as well, I think. However, the one of the strong place for the startup is USA, particularly the California. Uh, this slide showed the installation of the collaboration robot and traditional industrial robot. As you may see, the industrial robot is the robots, major robots, and the red one means collaborative robots are a little bit smaller compared to the industrial robots. However, the number of the collaborative robots keep I mean number of the collaborative robots are increasing annually a little bit and a little bit. So we expect the collaborative robots somehow uh, popularly used more and more in the future. So approximately 10% of the industrial robots are collaborative robot, I guess. So this slide show that uh, clearly indicate the collaborative robot share. I mean, take a share of the 10% of uh, 10% of shares in industrial robots. So when you look into the more details about the collaborative robots, uh, we can see the some major manufacturer of the collaborative robots. So one of the leading company which supply the collaborative robot is Universal Robot. Universal Robot is the first company who manufactured and supplied this collaborative robot. So previously, they actually took about 50% of the market in 2018. They took almost half of the markets. However, the it becomes more and more competitive. There are a lot of companies which making the companies that are making a many collaborative robots. So it's very competitive anyway. So recently, the uh, many of the companies are taking shares of these markets, and uh, the second one is which company? I'm not sure about that. Anyway, okay. And when you look at the markets, the there are some niche market and saturated markets and growing markets. So surgery and the research area is a little smaller one, and the growing markets are there are many applications and material handling, assembling, labeling, coding, uh, material handling, coatings, and there are some saturated markets, pick and place maybe, and the some weldings. There are some saturated markets. So I try to find some information in robotics associated with India. So it says India is emerging as hub for service robot with many startups developing innovative healthcare solution and domestic automation technologies supported by government initiatives promoting research and development. So this is, I guess, good news for India. So I also found some interesting data. So some companies, international companies, global companies like NVIDIA and ABB uh, try to promote robotics in India, and some domestic companies in India also uh, promoting robotics in India as well. So that sounds very interesting, and it might be a good news for India, I think. So I guess I time has passed quickly. So I would like to briefly mention about research opportunities and try to uh, conclude my lectures. Uh, so there are many research areas in robotics, and as I mentioned, robots should understand the environment and try to make some decisions and do some actions and interact with surroundings or environment and humans and other robots. So in order to achieve these all those uh, stuff, we have to study, we have to do research on the mechanics and the control and perception and planning and human robot interactions. More recently, the machine learnings are applied in robotics. So, traditional control may be replaced by the machine learning or machine learning based controller. So that'll be very interesting research topics. So machine learning or AI can be used for planning and control, perception, and design and modeling and fabrication in all those research areas. So all those traditional research topics can be uh, maybe maybe replaced by the machine learning, or maybe somehow we may import uh, import new technology. AI can be used in those traditional robotics research. So, for example, we can use AI to design the body of the robot or structures or mechanical parts, or in traditional we model the robot using dynamics and the kinematics. However, if the AI can understand the models or dynamics and the kinematics uh, itself, you know we can use the AI instead of the model. Sometimes, it is not easy to model the physical systems. And in human robot interaction, we can use AI to recognize environment, human motion, behavior, gestures, and speech intention and emotions, and try to understand all those human intention, I mean, the data and
Yeah,
try.
Professor, sorry for the interrupt. I think another keynote speaker is waiting to
Okay,
join.
okay,
Uh,
okay. Sorry.
sorry,
So,
sorry. Yeah,
okay. So
yeah.
anyway, I would like to let me conclude quickly. Okay,
Yes, yes, yes.
in a minute.
Yeah,
Okay, okay. Sorry about that. Let me change. Okay.
yeah,
So anyway, first I would like to mention that the technology is not perfect, and we see a lot of limitations in our current technology. So we can see some failure in robots.
yes.
Okay, this is several years ago, several years old. But anyway, the technology is not perfect, so we see a lot of limitations and challenges in technology. However, future is clear. I believe the we can see more human-robot cooperation and interaction in the future. I'm also expecting general robotics, and we are expecting physical embodiment of AI as a robot. So that'll be a future of robots, and there we can find a lot of research opportunities in those areas, I think. Okay, this is it, I guess. So I
Yeah, thank you, Professor. I requesting all the participants, if you want to ask any questions, I already unmuted your mic and your camera also I unmuted, and you can switch on your mic and you can ask if you have any questions still.
okay. Thank you for your
Hello,
attention.
sir.
Yeah, please.
Yes. Hello, sir. Good evening.
Yeah,
Uh, Sir, I'm a MTech student in robotics and AI, sir. So,
Okay.
what we'll be doing in this AI era, if you are pursuing MTech in robotics and AI, if you're not, if your college is not providing any practical experience, so how can you be succeed in this field, sir? What you will be doing?
I'm sorry. What is exact the question?
Uh, Sir, in what areas you are going to focus if you are pursuing in MTech, if you are in 25 years old, man, so what you will be doing in which area?
Professor.
In which area?
Professor, his
Okay.
question is that he is 25 years old. He is pursuing a PG. In India, we call it as a MTech. In abroad, you may call it as MS. And he's asking what is the area he need to focus in future.
Okay, that's a good question, I think. That's a really good question. Uh, no, we are facing a new paradigm for robotics. So, you know, there are some traditional research areas, and there are new AI-based research. So it is very difficult, but I believe, uh, as a young researcher, you have to more focus on the embodiment of AI in robotics area. So, we can still focus on the very traditional research areas. However, in the future, uh, you know, robots should be somehow composite with artificial intelligence. So I think you should a little bit more focus on the AI side. Learning, you have to be somehow familiar with the use of the AIs.
Yeah, thank you, Professor. I think any participant can give any feedback about Professor Yongshink. You can
Actually,
switch on.
Professor, I have some question. What would be the current research area related to robotics? Could you give me some insight so that we can go for some research? Because I have gone through some Columbia University professor. They taught some ROS, how to use using ROS to simulate some problem. So give me some problem so that we are able to do that in real means in a simulation world, and try to make some models so that it will be helpful for our society. So give me some your input related to research, which would be a better should be better for our
Okay. I didn't clearly understand your questions, but you mentioned that using the ROS and maybe simulating the robots or control the robots by using the ROS, right?
yeah, right. But what would be the current means research area is going on? Means current means what I need some problem definitions
Yeah,
so that I'm able to do that some work related to those area.
his
So I
question
need
is
a
that,
means.
yeah, Professor,
Is
his
there
question
any
is that what
problem
is the
you
current
are
research
facing?
area he need to focus?
There are many real
It's very
yeah,
difficult to answer.
I mean the questions and the problems in
There are so
robotics
many problems.
areas. So I'm not quite sure about that, but uh, the problem you are mentioning is not clear. But mm,
Please mute your mic. I think some people they are unmuted.
I hear many voices around here,
Yeah, yeah.
so it's
Okay, thank you,
confusing.
Professor. Thank you for delivering this lecture. I think another keynote speaker is waiting. Yeah.
Okay,
Yeah, yeah.
Thank you. Thank you.
And
Thank you.
thank you, Professor.
Okay, sir. I
You
will
given
send
your
you an email for this
valuable.
regard. Thank you for this.
okay,
Professor, I think
thank
Vishwanath
you.
also joined. I think he was here.
Okay,
Hello, Professor. So, good
Thank you,
evening,
sir.
Professor.
Thank you
Thank
so
you
much.
thank you so
hi,
much,
how are
Professor.
you?
You given your valuable time. I know you are always very busy and very hectic schedule. I know that. So thank you so much, Professor, for your valuable time. And
You're
participant, those
welcome.
who want to ask
Thank
some
you, sir.
those
Thank you,
questions,
sir. Thank you, sir.
we will
Okay,
reply that. We will
Yeah.
reply.
okay, it's
Thank
So
you.
good to
can we
see
get your
you.
Thank you
email
so much.
address so
Thank
we
you.
can mail you?
Yeah,
Can we
yeah,
get your
definitely.
email address
I will
and
share
Yeah,
you.
we'll
yeah, I
contact?
can
Yeah.
share. I can share. I can share. Okay, no
Professor,
issue.
if is it possible, please share your Skype ID so that we can discuss
Yeah,
further
yeah, yeah.
related to.
No, no, I
Yeah.
can share the professor
Okay,
email
you
ID.
can
Don't.
email me later.
Yeah,
Yeah,
Professor.
sure.
I
sure.
think you
I
can
will send
find
you an
my
email.
emails.
Yeah,
Okay.
sure.
Thank you,
Okay,
Professor. Thank you.
Thank you, Prof.
okay, bye.
Thank you, Professor.
What's your email ID, sir? Thank you, sir.
Okay, I'll be off.
Okay.
Yeah, I think
Is that okay?
the next
Okay, Professor. Okay.
keynote speaker, I think Dr. Ravi Kiran is from Triple IT, Triple IT Hyderabad. I think Ravi Kiran sir, please switch on your camera.
I think sir is joined, right?
Sir joined.
You can check it once.
Yeah, 1 minute.